We spent the bulk of the class practicing some of the stuff that we've been doing over the last couple days. I've got answers for you for all of it. Grab your work out. Let's go through it. I will take up any questions, comments, concerns you may have. Okay, so looking at the top part of my answers are all in context. I left them here on this page. I was working with a bunch of you guys on kind of B, C, and D here. There are a bunch of different ways that you can leave these answers, and they are totally acceptable. Any of these three expressions is fine for letter B. Some of you were distributing the C in on letter C. That's cool too. I didn't. You don't have to, but you're welcome to do it. Letter D, this was the way I chose to represent it. It's not the only way you can do it, so if you got something different you want me to check, let me know. Letter F. This isn't the only way to do letter F either. If you got something different and want me to check it, let me know. Comments, questions, concerns on any of these first. How many questions are there? A through F is 6, 8, 12 questions. So any of them anybody wants me to demonstrate? Like, well, how I went through, what I went through. Yeah.
D, I got,
which D? Hold the first one or second one.
Oh, second one.
Okay.
I got L2 minus 1 over L1 T.
Like this?
Yeah.
Okay. Let's take a look at how you would have done that. L2 equals L1, and then 1 plus A times T. So what was your first step?
Because the L1 is multiplying, so I put it under because I like took the other side and divided.
Okay.
And then 1 is being added, so I subtracted on the other side.
Okay. So at this step, if you do that, you're doing it the same way I did it. If you do it that way, when you subtract the 1 over, the L1 in the denominator here doesn't divide here. If that makes any sense.
So it's outside of the fraction.
So the minus 1 is outside of the fraction, yes.
And then A is multiplying with B, so I divided it into 2 and 1.
Yeah. So then you're going to have something. So then you're going to divide the whole thing by T. So, sorry, does that make sense, Brad? Why it isn't? If you want the way to get the answer that you had here, the first step you would want to do is distribute in the L1. If you did it if you distributed it instead of divided it over, you get L2 equals L1 plus L1AT. Then you'd subtract the L1 over, you get L2 minus L1 equals L1AT, and then you divide by L1 and T on both sides. They cancel there and there. And then you'd get A equals L2 minus L1 over L1T, which is very similar to what you got. But to go from the original question to your answer, you would have had to distribute in that L1 first. Otherwise, the negative 1 stays outside the fraction, and you get this kind of ugly mess. Does that make sense? Okay. Is there anything else here? Any of the algebra here anyone wants me to demonstrate? Yeah. Okay. D equals D over 1 plus AT. And we want to solve this thing for T. Okay. There's a couple ways you can start this. I think the easiest way to do this, it's similar to letter C, where we've got this whole object down in the denominator. Because the thing we're trying to solve is buried inside that, we need to multiply this whole denominator up to the left-hand side. So we're going to get d, and then I would leave it in brackets like this, 1 plus at equals d. And we're still trying to solve this thing for that letter t right there. So at this point, you have a choice of next step. At this point, this question becomes identical to the question that we just did with Brad. You can choose to distribute in the d here, and you're going to get a nice looking fraction. Or you can divide the d down, like we did, like Brad did here, and you're going to get this kind of ugly looking fraction. The only difference is this first initial step of multiplying this thing up. Jack, which way do you want me to do it? You want me to distribute in that d or divide it over? Okay. So if I distribute it in, d times 1 is d. D times at is going to be plus dat, and that's going to equal d. Because this is positive, I'm going to subtract it over. I know I've got dat equals d minus d, big D minus little d. And I'm going to divide, what am I solving for? T. I'm going to divide by d and a on both sides. And you're going to get t equals d minus d over dA. Which is, yeah, so that would be a much cleaner version of the answer that I had. Equivalent, they are the same. d minus d over dA. And if you want to see how to transform from one to the other, I can show you that as well. But either would work. Cool? Okay. At this stage, I had some students first semester that were panicking. This is the worst kind of algebra you're going to get all semester. If you can do this or are struggling to get through this, it gets easier from here, I assure you. Does anyone want to see any of the rest of these? Okay. Then the bottom questions look like this. Here's questions 3 through 6. D equals C over pi. And then I rounded B, 3B to 4 meters. I think it was 3.99 something. I rounded it to 4. 4 wanted to solve for W. That's it, solved for W. Well, that's one of the expressions you could get. The other expression would be P minus 2L all over 2 equals W. Either of these expressions are totally acceptable. And then I got the width is 6. The masses of aluminum and mercury, given volumes and densities, 5A is 149.04 grams. 5B was 938.22 grams. And then 6 and 7, you need 750 stereos. 7A is a 15-kilometer dipole, and B was a 40-kilometer dipole. Comments, questions, concerns on any of that kind of stuff? Yeah, you bet. So letter 5, so 5 letter A and B gives you, it's all about density. So if you've seen this in chemistry, it will be trivial. If you haven't seen it, it's really not that hard, and you'll see it here. So the formula that we're using here looks like this. It looks like a fancy script P equals M divided by V. This is actually the Greek letter rho, R-H-O, and it is the symbol that we use in chemistry and in physics to represent density. So that guy there is density. M is the universal variable for mass, and V is the universal variable for volume. And so in 5A, it says to find the mass, so the mass is what we're looking for, of 55.2 centimeters cubed of aluminum, and then it says that DAL equals 2.70 grams per cubic centimeter. What you need to recognize here is that if the units on this thing right here are cubic centimeters, yes. Where would you like me to go back to? Or would you just want me to stop talking for a second? Okay. Let me know when I can continue. Okay. So we're cool with the formula? Okay. So if they give you units that are distances cubed, so we have a centimeters cubed here, that has to be volume. Volume units are going to be either cubic things, or it'll be like mils or just liters. In this case, we've got cubic centimeters, so this needs to be recognized as your volume. And then DAL is 2.70 grams per cubic centimeter. This is the value for the density of aluminum. So then the formula, rho equals M over V, or density equals mass divided by volume, is just going to be the density of aluminum we know is 270 because they gave us that in the question. We're looking for the mass, so it just is going to remain there. And the volume that's given is 55.2 cubic centimeters. And then this thing, based on what I remember of your math skills, Ray Reed, will be trivial for you to solve. The mass would be 149. Just multiply this guy up. And then B is exactly the same. They give you the volume of the mercury, and they give you the density of the mercury, and you plug it in the exact same way. Does that help? Okay. So that's question 5. Anything else from the homework anyone wants me to see? Yeah, Brett? Or, yeah, wants to see me do.
I don't know, like we have 11.482 on question.
Yeah, that's letter B. Like, I mean, it's not spread. It's not specifically said A and B. The question, if you read, I'll read out the question. Use the density formula to find the mass of 55.2 cubic centimeters of aluminum, and then in brackets it's got the density of aluminum equals 2.7 grams per cubic centimeters, and it says and 82.3 cubic centimeters of mercury. So it wants to find the mass of each. So I split it. I gave my work as a part A and a part B. The question isn't, the wording of the question is meant to imply that find the mass of A, aluminum, and B, mercury. It's asking for two separate things. Anything else anyone wants to see here? Okay, 6 looks like this. A equals 15,000 plus 60n all over n. And it tells us in the question that A is the cost. I don't know why they wouldn't have just used C for that, but A is cost of producing n stereos. And this is given by that formula. How many stereos would have to be produced? It should be 80, not 800. How many stereos sets would have to be produced for the average cost to be $80? So that's why they're using A. A is average cost per stereo. and they want the average cost to be $80. So 80 is going to go in where that big letter A is. It's going to be 15,000 plus 60N over N. Oh, no, we're good. We're good. And you want to solve this thing for N. When you've got a variable that you're trying to solve in the denominator, never mind that it's in two spots. When it's in the denominator, your first step's going to be to multiply it up. So I'll multiply both sides by N. It's going to cancel on the bottom there. And you're going to get 80N equals 15,000 plus 60N. Then to solve for N, you got to bring all the N's over to the same side. So I'm going to take away 60N, take away 60N. We're going to get 20N equals 15,000. Then I'm going to divide both sides by 20. 15,000 divided by 20 is the same as 1,500 divided by 2. So that's where I got the 750. That makes sense, Brad? Yeah. Okay. If you're actually looking at all my work, it would have been confusing because I had the wrong number here to start. It should be 8,900. Okay, so like I was saying, the algebra and stuff that I get you to do in this first unit is the worst algebra you're going to have to do all semester. It only gets easier moving forward. So if you're sitting there panicking about the math, it'll be okay. Because I had a little bit of that first semester. If there's nothing else anyone wants to see from the homework, then let's flip the page. We're going to review some trigonometry. The Pythagorean theorem and the trig relationships are wildly useful. You'll see them used aggressively in, well, we'll use them a little bit of trig here in this course. It gets used extensively in Physics 12, and you'll bring in, well, it depends who teaches you Physics 12. There's a few methods for doing things. If you've seen sine law and cosine law in your Math 11 courses, those get used heavily in Physics 12. We don't use them here. If you haven't seen those, you will at some point, hopefully, be exposed to those two laws. At this point, all we need are the regular trig relationships. So if you take a jog down your memory, the Pythagorean theorem, what is it? Yeah, Ray Reed, say it louder. Yeah, it's a squared plus b squared equals c squared. And it is a relationship that exists in all right triangles, so you have to have a 90-degree angle in that bottom corner there for this relationship to hold true. If you don't have a right angle triangle there, then it's not this law that holds, it's actually cosine law, which we're not going to look at. But for right angle triangles, this is true. Now, for a squared plus b squared equals c squared, we have to be careful how we label the sides. How do the sides get labeled? Which is the only side that matters in the label is side C, and it's always which one? Yeah, the hypotenuse, the one across from the squared. So across from the squared, every time that side gets labeled C, it's the only one that matters. The other two are going to get labeled A and B, and it doesn't matter if you call this one A and this one B, or if you call this one A and this one B. It doesn't matter. This relationship holds true. A squared plus B squared equals C squared. Hands up if you've seen cosine law before. Okay, cool, most of you. When you were taught cosine law, did your teacher show you the relationship between the regular Pythagorean theorem and the cosine law? Like, do you want to, like, Ezra's saying no, that didn't happen? Who'd you have, Ezra? Okay.
It's like you take
Okay.
to find the hypotenuse, you take the opposite and adjacent.
Oh, no, not there. Not yet.
Oh.
No, that's cosine, not cosine law.
Oh, okay.
There's a difference between cosine law and just the cosine trig function. So maybe I'll ask my question again. How many of you have seen the cosine law? Less of you, okay? Cosine law looks like this. C squared equals A squared plus B squared minus 2AB cos big C. Have we seen this before? Some of you have. Kai, have you seen this thing? You said you weren't sure.
I feel like I have, but
Okay.
I don't remember.
Okay. So this is cosine law. Different than just cosine. If none of you have seen this before and we don't actually need it here, Brad, you have seen this? Okay. What did you have for math? Oh, yeah, you've taken pre-calc 11 already. Okay. Yeah, you would have definitely done it in there. Did he show you the relationship between the Pythagorean theorem and the cosine law? Okay, I'll show you. You know what? We'll leave this. If that many of you have not seen, so first semester, I had a bunch of students who are like, yeah, totally. This semester, if you haven't seen this before, this we will leave till grade 12. We don't need it. There is just a cool relationship between these two, but if I would just add more confusion, forget I even said anything. The Pythagorean theorem, though, we will need a squared plus b squared equals c squared, where c is always the length of the hypotenuse, and we'll use that here in a second. Okay, then we've got your trig relationships. Those you should have been exposed, some of you would have been exposed to them in Math 9. You should have been exposed to them in Math 10, unless you had me, and then it was that snow week is when I was going to do it, and we lost the whole week due to snow. So if you had me for Math 10, you didn't see it. The trig relationships, the handy-dandy way to remember these is SOHCAHTOA. And this gives you a relationship between three ratios and various sides in a right angle triangle. So I'm going to label this guy here. That's our right angle. So uses sine, Ka uses cosine, and TOA uses tangent. This is meant to be a review. So if this is the first time any of you are seeing this, please come tell me after. And so just by way of review, how we use sine, cosine, and tangent to solve for different things is we need to designate what angle we're working from. So in this case, I'm going to say that this angle down here is the angle that we're working with. I'm going to call that guy theta. And so if this is the angle that we're working with, what are the names of the sides in this triangle? Brad.
The C angle, the lowercase c, is hypotenuse.
Yeah, this guy up here. What we called C for the Pythagorean theorem is the hypotenuse.
And then the line facing up is opposite.
Yeah, because this guy's across from the angle that we're using. This is going to be the opposite side.
The last one is
Yeah. Adjacent means beside. It's the angle. Sorry, it's the side that is next to the angle that we're using. That's not the hypotenuse. So once we designate an angle to work from, then we can label the opposite and adjacent. If I had picked this, I'll put a little pink dot up here. If I had picked that little pink dot instead, the hypotenuse would remain the same because it's across from the 90, but these two sides would be labeled different. The bottom side would become the opposite side. The tall side, or the top side rather, the vertical side would become the adjacent because it would then become beside that pink dot. So these two would switch if I was referencing that pink dot instead. And then the way these ratios work is that the sine of that angle, and sine is just an operation done on your calculator, the sine of that angle, whatever it is going to be equal to the length of the opposite side divided by the length of the hypotenuse the cosine of whatever angle that guy is going to equal the length of the adjacent side divided by the hypotenuse, and then the tangent ratio of whatever angle that is going to equal the opposite length divided by the adjacent. So I'm going to do one example to just kind of jog the memory, hopefully, and then I'll get you to play with a bunch of these questions. Here's the question. The example I'm going to do is this guy down here. It says to solve the following triangle. For those of you who remember remember doing this in Math 10, what does it mean to solve the triangle?
On the unknown side. Right?
Almost. When you say the unknown side, Lachlan, how many unknown sides are there? Which, yeah, there's two. This bottom one we don't know. This 30 is the angle. That bottom side we don't know. That vertical side we don't know. And we actually don't know that third angle. It's going to be trivial to find, but we don't know it yet. So when it says solve the following triangle, what it's asking you to do is find all missing sides and angles. So I'm going to label the things we don't know. We'll call that guy X, we'll call this guy Y, we'll call this guy Z. And it doesn't actually matter what order we go about solving these things. There are easy ways to do these. You can make it as complicated as you want, but there's some simple ways to solve this. What's the easiest way to solve one of these variables? Kai?
Z is 60.
Why is Z 60?
Because there's always 180 degrees in a triangle.
You betcha. So here's one of the relationships we're going to use. Angles in a triangle add to 180 degrees. So if they add to 180 degrees, that's 90, that's 30. So 180 minus 90 is 90, 180 minus and then 180 minus 90 is 90, 90 minus 30 is 60, and we're done. So Z is easy to do. Let's go to x or y. It doesn't matter. Pick one, someone. Which one do we want to solve for next?
X.
Sure, Kai wants to do x. Okay, if we want to solve this thing for x, now that we've got an angle measurement up here for z, we can choose which angle we want to use to start from. We don't have to use the 30. We could use the 60. Best practice when you're doing stuff like this is if your final answer for one of these variables is rounded, don't use it for subsequent algebra if you can avoid it. But because this is exactly 60, we could use this 60 or we could use this 30. I'll show you both ways. If I'm using the 30, then side x is what side? Yes, someone said adjacent. And then what's the other known side in this triangle? The hypotenuse. So then if I'm using the 30, x becomes my adjacent, h is my hypotenuse. Which of these three trig ratios do I have to use to solve for x? Someone said it over here. Cosine. So then the cosine of the angle we're working from, 30 degrees, is going to be equal to, remember it's adjacent over hypotenuse, so it's going to be x over 12. To solve for x, I'm going to multiply by 12, and we're going to get x equals what? Kaylin, I saw you pull out a calculator. Oh, were you not calculating? Oh, you just pulled it out? Okay. Sorry, I won't call you out so aggressively next time then. 10.4. Cool. That was not the only way we had to solve x. We could have done it another way. If I'd wanted to work from the 60, then instead of x being the adjacent, if I'm working, I'll use a different color. If the 60 is the one that we're using, then x becomes what side? It would have been the opposite side. So then instead of cosine, we would have used sine. We would have said that the sine of 60 is equal to x over 12. We would have multiplied both sides by 12. And we would have found that, those cancel there and there, 12 sine 60 is the same value. 12 sine 60 and 12 cos 30 are the same. You could have used either one. At this point, it becomes about your choice. And then the last one is to go ahead and find y. Now that we've got z and x, we can find y a whole bunch of different ways. If we wanted to use the value we found here for x, we could use the Pythagorean theorem, right? We know two sides. We could find the third. If we wanted to use the 30-degree angle, y becomes the opposite side. We could use opposite over adjacent or opposite over hypotenuse. If we wanted to use the 60, then y becomes the adjacent side. We could use tan again, or we could use cosine. We almost have too much information. We got 5 different ways we could go about solving for y. As it is, though, my recommendation is to always, as much as possible, avoid using values you calculate and have to round, which Kai did. It wasn't 10.4, it was 10.39 something. So I'll call that 10, which you call 10.4. So I'm going to avoid using x to solve for y. So if I'm going to avoid doing that, I want to use the 30. I want to use the 12. So then I'm going to use the opposite and hypotenuse. We're going to say that the sine of 30 is equal to the opposite side y over 12. I multiply by 12, I multiply by 12, and we're going to find that y equals, I got 6. Six exactly, no rounding. But we could have done it a whole bunch of different ways because we have all of this extra information. So now we've got a value for z, we've got a value for x, and we've got a value for y. Comments, questions, concerns on what I've done. I'm hoping this is review. If this is not review and I've lost you, please call me over. Okay, then what I'm going to get you to do is practice with some of this trig. There are 7 questions I want you to do down here. Forget that this says bonus. I actually want you to do it. All at number 7. For each one of these, you're going to have to draw, so there's not enough space on here. I'm going to review real quick some of this language here. Angle of elevation in question 1 and angle of depression in question 2. This was language you would have been exposed to the first time you looked at trig. Does anyone remember, what is the angle of elevation? What do we remember?
The angle between horizontal line and the hypotenuse.
Yeah, if the hypotenuse is going up, yeah. So the angle of elevation is if you are looking straight ahead and the way the question is taking you is that you then have to look up at something. This is the angle of elevation from the horizontal to the top of something. This is angle of elevation. And angle of depression is the opposite. It's if you're looking horizontally and then to see whatever it wants you to see, you have to look down. This angle there becomes the angle of depression. So I'm going to get you to play with these 7 questions. I'll come around and help as needed. You can use the whiteboards. You can use your own paper on your market say giver. And I would encourage you to use the people at your table. Do what you got to do, man. Yeah. Your market say giver. There. Those are the answers.
No, that's not.
Oh. Okay.